Hi guys, in this particular video we will learn the chapter prerequisites of EDC2 and the topic is AC analysis of BJT, which is very important when we are dealing with multi-stage amplifier analysis as well as design point of view. This is step number 2 for the analysis of BJT as an amplifier. As we have discussed, step number 1 is DC analysis of BJT. This is your step number 2 for AC analysis of BJT. Now in this AC analysis of BJT, first of all we'll have to learn why AC analysis, because in DC analysis we learned that only for DC supply what will be the nature of the BJT when particular bias network is considered. Now in AC analysis we don't have to consider any DC supply, then we'll apply only AC signal. Then how that particular circuit will give the response as an output voltage, then we'll have to combine that DC and AC, then we will be dealing with BJT as an amplifier. So this is step number 2 where we'll learn AC analysis of BJT. The first and very important, we have to note that all DC supply should get short circuited. That means it should get connected to ground, right? So all DC supply, that means VCC is connected to 0 volts, okay? VEE also connected to 0 volts. So basically what we are dealing here, we are just converting this particular supply towards the short circuit. We are not at all applying any DC supply, we are just applying the AC signal, and then we'll identify that what will be the nature of the BJT bias circuit as an amplifier. Okay. Now to learn this particular AC analysis as BJT, we are dealing with the modeling of the BJT. So modeling means what? So BJT ko ramp walk karna hai? No. So basically BJT has to represent in a different way. So I'm representing that BJT in different way. BJT is basically the active device, okay? So I'm converting that BJT configuration in a small signal model, okay? So that particular thing is called as modeling of BJT. So I'll represent this BJT in different passive network, passive circuit or independent dependent sources, okay? These modeling are of 3 types. One is with RE model. Another is with RPi model. And another is called as H parameter model. RPi model is also called as hybrid pi model. Okay? So don't make confusion in between hybrid pi model and H parameter model, because H is for hybrid. So hybrid parameter model is totally different and hybrid pi model is totally different. So once we say that model this particular BJT using hybrid model, so hybrid model means your RPi model. H parameter models means your H parameter model is a hybrid parameter model, okay? So let us understand one by one. Whenever we are learning this particular BJT, let's say we are considering more or less, we are using NPN, where this is your collector, this is your emitter, and this is your base. So basically I am replacing this. Modeling means what? Means I am replacing BJT by resistances, capacitances, and dependent sources. Okay, so replacing BJT by resistances, capacitances, and dependent sources. Okay, so let's try to figure out the first model as RE model. Okay, we'll not go in detail, but we will make the comparison at last about these particular three models, and we'll make the relation between few parameters related to these three models. Okay, RE model, where we will say that RE model is nothing but where this BJT is completely replaced by this particular circuitry, where this is nothing but your base, this is nothing but your emitter, and this is nothing but your collector. Okay, and this is your current source. As it is coming from the collector branch, it's nothing but the collector current, and collector current I can replace it by base current by multiplying with a factor beta. Okay, so I can say that it's nothing but the base current IB. Okay, and where this IB is nothing but over here. This resistance is called as beta into RE. Okay, so I can say that this is nothing but the RE model. I'm replacing BJT by this RE model. Next model we will consider as RPi model. Okay, in RPi model we will say same configuration but the values are different. Okay, this is collector, this is base, and this is emitter, right? So base, emitter and collector at the same place. This resistance value is different. That value is RPi. That value is RPi. And the voltage across this RPi is nothing but Vpi. Okay, voltage across RPi is Vpi. Current flowing through this particular dependent source is Gm into Vpi, right? Where Gm is nothing but your transconductance. Trans for transfer, conductance is nothing but the inverse of that of resistance. Now the third configuration is nothing but your H parameter model. Okay, this H parameter model is very simple. This is your HIE, this is your HFE into IB. Okay, this is collector current, this terminal is C, this terminal is B, and this terminal is E. A very important fact is, even though I can draw these three models of BJTs, even though I draw these three models of BJT, I should learn the comparison of all the parameters I have written over here. Okay, so we'll learn the comparison of these parameters. So although we have three different models of BJT, these three models are representing BJT only. So can I say that whatever value which I have got it over here, beta Re, is same as that of your RPi, is same as that of your HIE. Okay, so we'll equate beta Re Vpi and beta Re RPi and HIE, these three resistances, input resistances. Okay, so same way I can replace this beta IB by HFE IB and GM Vpi. So I can equate beta IB, GM Vpi and HFE IB. So we'll be getting two equations by three particular models, and we'll get the relation between the models as beta Re is equal to RPi is equal to HIE. Okay, so in any numerical, if they have given HIE and they ask us to analyze using RPi model, so I can easily say that HIE is nothing but your RPi. Okay, so in a second, this is your first equation that we have got. In the second equation, we will be equate beta IB, which is for RE model, then GM V pi, right? This is for R pi model, and HFE IB for H parameter model. So this will be your second equation. Now if we equate each and every parameter, we'll get the relation in between two. Okay. Now here important fact is, what is V pi? V pi is nothing but the voltage across this resistance R pi, and obviously as B is connected over here, so IB is nothing but the current which is flowing through the R pi. So IB is the current flowing through the R pi. IB multiplied by R pi is nothing but V pi. So we can make another equation, that is IB multiplied by R pi is nothing but your V pi. Okay, so we will be getting GM into IB into R pi is equal to beta into IB is equal to HFE into IB. So for example, we'll get the relation beta is equal to HFE is equal to GM into R pi. So if they have given beta and R pi, if you want to find out GM, we can easily find out. So this is how we have to play with all the parameters of the three models. Once we are very much familiar with all three models, then we can easily move ahead for the example of AC analysis. Now we'll play with particular type of AC analysis. Okay, total AC analysis depends on the DC values. Okay, so without any DC analysis we cannot further for AC analysis. Okay, so we will say that for AC analysis we have to convert our complete circuit into its AC equivalent model. Okay, first of all we have modeled that BJT into three models. Okay, by using any model we can convert that complete circuit into its AC equivalent model. So first of all we will try to do the AC analysis. So as a part of AC analysis of BJT, we have to know how to draw the AC equivalent circuit. There many people get stuck to draw the AC equivalent of BJT if more complex circuit is given in the examination. So let us consider that a very simple network that is same as that of earlier one, voltage divider network, and I did simplify this particular network as a Thevenin's equivalent circuit. So that also I will draw, right? So this will be your VCC, this is your RC, and this is RE. Okay, collector, this is emitter, and this is base. Input, and this is connected to your output. CC2 and CC1. Important fact of CC1 and CC2 is, if I have n number of stages such that VO is connected to another stage of BJT amplifier, such that output is connected to the input of another BJT, I can say that how I can separate it out each and every stage. So this coupling capacitor basically divide these particular DC circuits into separate form, because capacitor don't allow DC, allows AC only. Okay, so that's why we use coupling capacitors. Now let us try to figure out what will be your AC equivalent model. So we'll draw AC equivalent model. First of all, I'll repeat once again what we'll have to understand that while doing the AC analysis. First thing, I have to convert DC supply. I'll have to convert DC supply to 0 volts, right? And then we'll have to use modeling. Whatever modeling we have discussed so far is approximate modeling. Okay, so we'll do more or less approximation when we are dealing with the analysis on design. Okay, so let us try to have first of all the modeling of only this particular part. Okay, that is nothing but the BJT. So we'll start it over here. We know that using RE model. Let's say using RE model first. Okay, if I'm using RE model, then let's say this will look like your BJT RE model, where this is your beta IB and this is your IB. This is your beta into small RE, grounded, emitter. Okay, this is your collector, this is your emitter, and this is your base. Hold on, I have not yet connect any capacitor in parallel with the emitter. If I connect this capacitor in parallel with the emitter, I will get more gain, right? So that capacitor is called as bypass capacitor. So basically, if I am operating for DC analysis, I will be using RE, that resistance RE, into picture. But if I am using AC analysis, I am keeping all the capacitances as short, right? So question arises, why? So we will use short all coupling capacitors. So we will say that question arises, why? So as frequency will come into picture over here, so as frequency increases, my XC will tend towards 0, right? So XC will tend towards 0, so we will short this, right? So this coupling capacitor will get short, and this bypass capacitor, if it gets short, RE, capital RE, will be redundant in nature. So that's why if I short this capital CE, that is bypass capacitor, so I will write it over here, this is called as bypass capacitor. Okay, so we will say that this resistance is beta RE, emitter will get shorted by capital CE, that is at towards the ground. So that's why emitter is directly connected to ground. Then we have to look at the base as well as collector side, how I can draw each and every resistor, how I can connect each and every resistance towards the zero potential. So let's say base is connected to R2 and R2 is directly connected to the ground. So I can say here we will draw the resistance R2 which is connected to ground directly. Okay. Similarly, base is also connected to R1 and it is connected to plus VCC, and plus VCC is connected to the zero potential. That means also R1 connected to ground, but in parallel with R2. So here I can say that R1 as well connected to ground. Okay. So base side, I can say CC1 is shorted, so from base only we'll be getting the input supply. So here my input AC voltage is applied. Now let's move towards the collector side. At the collector side, I have connected the RC, right? So I will just apply the RC, and RC is connected to VCC. VCC is also grounded, so we'll say that this is also connected to grounded, and collector say I'm getting the output as CC2 is short circuited, we'll be getting VO over here. So this is how we have used the RE model to draw AC equivalent circuit of this given circuit, right? A question arises, okay, RE model is done, then we have to move to finding for some particular parameters, right? So one parameter that we have to find is voltage gain. Second parameter we have to find is current gain. Third parameter we have to find out as input resistance. And fourth parameter we have to find out as output resistance. So these four parameters finding is very important as far as analysis is concerned. When we deal with the design, exactly ulta we have to deal. So in the design, each and every parameter will be given, voltage gain will be given, the range of the voltage gain will be given, and we have to find out which kind of resistance, which valued resistances we have to apply so that it will give me the given range, right? So let us try to figure out first analysis point of view using only RE model. Okay, so how to find out the voltage gain? Now in this voltage gain is nothing but VO divided by VI. So we have to move from VO and reach towards VI. Whatever ratio we'll be getting, that will be your VO divided by VI. So basically we will try to get one particular agent, right? So in these kind of circuitry, whatever voltage gain, current gain, input resistance, output resistance that we have to find out, that will give you by using 5 fingers. Now let us understand what is 5 fingers. 5 fingers is nothing but 5 laws that we have already learned. First law is Ohm's law. Second law is your KCL. Third law is your KVL. Fourth law is VDR, that is voltage divider rule, and fifth law is nothing but your current divider rule, that is CDR. Okay, so if we learn these 5 fingers, that are nothing but the 5 laws that we have learned in earlier semesters. So if we learn that, then it will be very simple to analyze what will be the exact value of voltage gain irrespective of any kind of mode of operation for the BJTs. So we will not go in detail to find out what will be the value of the VO divided by VI, but just in brief, I can say that we will require one particular agent. So that may be for RE model, that may be IB, for RPi model that may be VPi, and for H parameter model as well, that will be IB. So let's try to get how we will move further with using agent. VO divided by VI we want to find out, right? So we will not find out first VO divided by VI. We will first find out VO divided by IB. Okay, so my IB is nothing but the agent, right? And then we will find out what will be the value of IB divided by VI, right? If we make this into 2 steps, then it is very simple to understand what will be the value of voltage gain. Okay. In a similar manner, we have to find out what will be the value of current gain. So in the current gain finding, we will just find out what is the IO divided by II, right? Now you can easily get to know that IO divided by first IB, yes, very good. Then IB divided by II. Here I can use current divider rule to find out IB divided by II, right? Here I can use the Ohm's law to decide what will be the ratio of IB divided by VI or inverse ratio of VI divided by IB. Okay, VO divided by IB as well, we will use the KCL at the output stage, and IO divided by IB as well, we can use the KCL at the output stage. Okay, so this is how you have to deal with each and every parameter, that is nothing but all 4 parameters for exam point of view. Input resistance is concerned, just look at this particular side, you'll get to know that R1, R2 and beta RE are connected in parallel. So I can say that here you can easily write the value of Ri. Here at the output side, you can easily write the value of Ro. Okay, so this is how we have to deal with the AC analysis of BJT, right? Whatever we have drawn is for RE model. We can replace this particular circuit, this particular complete circuit, I can replace it by any another model, either for RPi model or H parameter model. And as we know the relation amongst themselves, we can also find out the parameters of voltage gain and current gain, even if any another parameter of any another model is given. I can figure out what will be the value of voltage gain and current gain, whatever the parameter is required. Okay, so this is how we have completed your first chapter, that is prerequisite of EDC 2, right? So learn some AC analysis, DC analysis, diodes, then BJT structure, whatever operation working principle of BJT is concerned, just learn little bit out of it, and then we will jump into the first introductory module of your whole EDC, that is nothing but your MOSFET. That is comparatively very different aspect to study the transistor. Okay, so thank you for watching this particular video and subscribe Ekeeda videos and learn out of it. Thank you.